Autodesk's design and manufacturing portfolio has all the tools to enable organizations to work most effectively from initial concept all the way through to production. These tools enable data to flow through different processes in the product development process, automate repetitive tasks, and drive insights to improve your business. Now let's check it out and see how. In this example, the design team has been tasked to work on the connection mechanism for a curtain wall, which once consisted of multiple components. So the team decided to use Fusion 360's generative design to help the team explore many different alternatives based on different setup criteria, manufacturing methods, and materials using cloud computing to solve many different iterations simultaneously. In the same time, an engineer can model, validate, and ensure manufacturability of just one concept. Generative design can give that same engineer numerous designs that are fully validated and manufacturable based on the most common manufacturing methods. Coming out of generative design with an editable solid model allows you to easily make necessary changes to the model before going to print preparation. Now that we made the required parametric changes, let's send this design to Autodesk Netfabb. We will start by orienting and placing the part on the printing platform. Netfab allows you to efficiently organize parts whilst keeping material usage and build success front of mind. Support structures needed for supporting overhangs are highly customizable, but easily automated once your customized settings are tuned in. With the build prep done, you can either send directly to the machine, or for metal prints such as this one, perform a full simulation of the build before running it. This simple check ensures you avoid costly build mistakes and mitigate warpage issues created by flagging them virtually before even creating a failed build. Now that this design is set up for the additive manufacturing process, we can start to work on ensuring that the connecting faces, mounting features, and more are in the proper tolerance using subtractive manufacturing. Fusion 360 gives us the ability to parametrically design the soft jaws to hold our part in the milling machine effectively. Now let's take our part and soft jaws seamlessly into PowerMill to define the machining setup. First, we could select our Kurt vise as our work holding and place it right in our machine to accurately represent our setup in the real world. Next, we can start to create safe toolpaths using PowerMill's advanced toolpaths, dynamic tool tilting control, and machine collision detection. But to verify the G-code posted from PowerMill, let's move over to CAMplete for G-code verification to ensure the machine behaves as expected. In addition, we can use CAMplete as a centralized post-processor from various CAM packages used by our team. Now that we have all the processes set up to manufacture our part, we can ensure that our part meets our specifications and tolerancing with Fusion 360's on-machine verification sequences, commonly known as probing. We can then visualize whether the manufactured part is within tolerance right on the CAD model, which can help enable the programmer to make more informed decisions for the next time they program this part. After seeing this workflow, you must check out Autodesk's design and manufacturing portfolio, which will ensure your team's data flows seamlessly throughout your organization, which in turn will automate repetitive tasks, ultimately driving insights to improve your business.